All right, welcome to technical session number 18, Introduction to Networking. Starting to really get into the meat and potatoes of this particular cohort. We started out talking about the bits and pieces of a computer. We got into motherboards, we got into RAM, CPUs, display devices, connectors, all that kind of fun stuff. We're starting to put it all together now, and we're going to be talking about networking, setting up LANs and WANs and PANs, all that kind of fun stuff. We're going to be talking about hexadecimals and MAC addresses and what do we use these fun things for. We're going to be getting into wiring standards for cables, for twisted pairs. Yes, we do need to know that. We're going to be talking about the different types of wires we're going to deal with. We're going to talk about various connectors with regards to fiber optics. A lot of stuff to get into, and we're going to work through it one piece at a time. Our objectives are going to be to define networks and give examples of networks. We're going to be able to identify devices used in networks, your hubs, your switches, your routers, bridges, repeaters, all that kind of fun stuff. We're going to be talking about different types of network cables and connectors. We're going to be talking about network topologies. How can you set up networks into different logical and physical topologies? We're going to be talking about ways to recognize some of the most common network tools. As we move through this, we wanted to maintain an adaptability mindset. We're going to be throwing a lot of information at you, and we need you to kind of move with the punches on this one. We're going to go in a deep dive, talk about a lot of these things. We need to adapt to that scenario. We need to have a growth mindset, understanding that all of this information will inevitably help us in the future, and that what we're doing right now is going to pay off dividends for us. First, what is a network? What exactly do they mean when they say this? It is basically a group of computers or devices that are connected together to share information and or resources. That is the long and short what a network is. It must provide communication, it must provide connections, and it must provide services. Services could be computational power, it could be applications, it could be files, it could be music, it could be movies. It's just different types of resources that could be provided over this network, and ways for these systems to communicate with each other. Now, some of the biggest network components we need to be aware of. We need to be aware of the client, the server, the network devices, and media. Who is the client? That's the end user. In essence, your computer. They're the ones who are trying to access the network itself and utilize the resources being provided. Examples of this would be like a PC, a laptop, smartphone, tablet, what have you. Server is a device that serves up those resources. It provides those resources for the end users or the clients. This could be an email server, a web server, a file server, a proxy server. We'll get into a lot of these a little bit later this week when we talk about network servers in general. But these are providing specific services and or resources to end users or clients. Network device helps to create the network itself. It facilitates that communication. So your hubs, your switches, your routers, access points, wireless access points, and various other things help facilitate that communication amongst the network. It provides like a pass-through of that information. And then the media in which you are connecting. It could be wired or wireless. You know, how physically are these things connected? Are you using Wi-Fi, fiber optic, coax, twisted pair, POTS? What are we using to pass that information back and forth? All right, so a topology is the arrangement of connections between computers. There's a multitude of ways that you can connect computers together. And this is like a basic layout as to what they are. So we have our mesh, our ring, our bus, our star, and our hybrid. Go ahead and break out our annotator here, because I don't have my digitizer handy. I'm going to give Avery an eye twitch. So the first kind we have is our mesh network. So, say each of these squares, we'll pretend they're square. Represents a computer, right? So how a mesh network works is each computer, so each of these are a computer, each computer is connected to every other computer. So every single computer on the network has a connection to every single other computer on the network physically. So it makes out like a mesh, right? So it has its strengths and its weaknesses. Each of these computers would be considered a node. So the strength is, if I cut out this computer right here, it doesn't bring down the network. All the computers can still talk to everyone else on the network. So it's a very robust system. It's very hard to bring down. So it has a very, very large fault tolerance with regards to the network itself. Who can think of a downfall to this network?
It's hard to, it's expensive to maintain or connect, I guess.
It's expensive to set up. I mean, think about this. This is just 5 computers. So it's 5 computers. We've got, 4 network cables coming out of every single computer. Start scaling that up. There's actually a formula to figure out how many cables or connections you're going to need in a mesh network scenario. So it's n times n minus 1 divided by 2. And n stands for nodes. So here we have 5 computers. So 5 times 5 minus 1, so 5 times 4 gives us 20 divided by 2, 10. So we have a total of 10 cables that are needed to make the connections for this mesh network. Let's scale it up. Let's go to 10 computers. 10 minus 1 divided by 2. So 10 times 10 minus 1, so 10 times 9, it's 90 divided by 2 gives us 45. You see how quickly that's scaling up? It's exponential. So now we need 45 cables and connection points. That's just for 10 computers in your network. Imagine that. How many ports do you think you would need on the back of your computer just to be able to communicate in a mesh network? So that is the downfall of it. It's very costly. I mean, you think about that, you need 45 cables just to hook up 10 computers. That gets expensive really quick. But the beauty part is if one of those computers breaks, it doesn't really affect the network. Everybody can still talk. So there are positives and negatives going into these particular networks. So next, we have our ring topology. So we'll draw out our same computers here. It's a little bit simpler. This is a much older technology. So you have one computer is connected to the next one. And this one goes to this one. And this one goes to that one. And that one goes to this one. So it forms kind of like a ring. It is a closed connection. Relatively easy to set up, not too expensive to get into place. However, it has one major flaw.
It's hard to add another device, connect another device.
That is a good one. Yes, it is difficult to add another device into a ring topology. But the biggest threat is if a single break happens either in a computer or in the cable itself, like if this cable went down, the entire network goes down. It has zero fault tolerance. So it's very easy to bring down a ring network.
Can you repeat that? I'm sorry, can you repeat that?
Sure. If a single node or cable is broken, if there's any break in the connection on a ring, the whole network goes down. It can no longer communicate. Unlike the mesh network, which was very robust and you could continually bring down nodes, and then all remaining nodes would still be up and able to talk. So that is the big difference between those two. Any questions so far with ring and mesh? Do you have a question, TK?
Huh?
Did you have a question? You were still off mute, so I was just curious.
Oh, I'm sorry. I didn't realize I was.
No worries. No worries. All right, so that's ring and mesh. Next. Go ahead and get rid of this. And I will come over here for this one. Draw on a line. So we get 4 nodes here. And we have the bus network. This is a very old network topology. It's older than the ring. This is one of the original ones. So you would have 4 computers attached on a single line. And originally, like when you'd go into an office, they would have one really long line of coaxial cable, and they would hook all the computers into that cable. And know it or not, when you're installing a new network port at an office, they call it a drop, even though you're just hooking it up into the wall and next to the customer. And the reason they call it a drop was originally these coaxials ran through the drop ceiling up above you, and then they would go up, and they had this box that they would hook in, and it had what's called a vampire connector, which was just basically a metal spike that went into the coax to create that connection, and then they would drop down a cable from the ceiling so that you would be able to hook into that network. So that is why they call it a drop. But originally this was on a bus network, which is just this single line right here of units. They don't come around and connect to each other like the ring. And at the end of each of these lines, they have what is called a terminator. If you do not have a terminator on the connection is lost. That will actually bring down the network if there is no terminator connected to the end of a bus network. Because what the terminator does is it reflects the signal back down the line. Because what's happening is the signal is just passing back and forth down the lines. And whichever unit is needing that information, they're taking that information. So if the terminators are not there, signal is lost. Also, if a single unit, like a single node or line is broken, the entire network goes down. Also, no fault tolerance. Yes, Rienzi.
Did you mean that there's a terminator on each end, or just at one end of the line?
Thank you for the clarification. There is a terminator on each end, because the communication is going back and forth, and the terminator is reflecting that communication back down the line. So yes, there is a terminator on either end of the bus. And this is typically a coaxial connection, and they use, who wants to tell me what type of connector? You got a 50-50 shot.
Is it a FJ45?
No.
What, a coaxial?
It is a coaxial. It's coaxial cable. So what kind of connector would they use to hook up these computers together?
The 6th, the category 6.
Is
Oh,
it
that's
B? C?
There we
TP
go.
something?
B and C.
Oh, you're talking about, oh, sorry.
Yeah, B and C for coaxial, because it has those T connectors. So what would happen is out of the computer, you might have a T connection. You put one B and C on one side, one B and C on the other. They're all connected together at that point. That allows you to hook up multiple units. So B and C, that is bus. Do we have any other questions with regards to bus? It is, we do still see the bus being used in network segments nowadays, but we'll talk about that in a little bit. You don't use it straight for a full network, but for segments of the network, you may. So, all right, so got the ring taken care of. Now we will talk about the star network. So back over to our original 4 here. A star network has a central device that is used for communication that has lines going out to each unit. And this could be either a switch or a hub.
Oh, yeah, I do have one more question, sorry, that I.
Okay.
Okay, about the previous one, the terminators are just computers as well. They just.
No, they're not computers. They're actually devices that you put on the end.
Oh, okay.
So, no, you can't put a computer on the end. If you put a computer on the end without a terminator on it, it will actually not function. So there actually is a device called a terminator that goes on the end of that coaxial cable that reflects the signal back. All right. Now, or excuse me, it terminates the signal. Apologies. All right. So star network. It utilizes a centralized device right here, which would be a switch or a hub that is individually connected to each node on the network. This is probably the most common network configuration you will see today. Small home and office, as well as in enterprise. You do not necessarily see it because a lot of this stuff is run behind the walls and into the server rooms themselves, but you will see huge bundles of wires going in and going into switches, and those switches are managing the communication between all the other devices in the network. So the nice thing about the switch or hub is if this line or this computer goes down, the network stays up. So it's still able to function. Although it does have a weakness, which is a single point of failure, and that is the switch or hub itself. If the switch or hub itself goes down, the entire network goes down with it. If a single node goes down, the network can withstand it. So you have a single point of failure at the center of the star. Questions so far?
You said if one goes down, the others will work, right?
Well, if a single node, so if
That's
this
what I mean.
if this computer goes down, you're okay. If the line to the computer breaks, you're okay. But the problem is if the switch or the hub goes down, the entire network goes down. Questions with regards to the star network? We'll have some better graphics on the next page that'll kind of explain it, but we'll get there. So mesh. Mesh network is a hybrid network. Apologies, hybrid is a combination of two or more networks. Most common you will find would be star bus. So this would come in, come out, and you would have a router. And then that would connect to a bridge. And then would connect to, say, another star network. So we have the star here, we have the star here. We are connecting them together with a bus. So that would be a hybrid. Yes, Rienzi.
So it says here it uses one or more networks to combine. So if it was two star, can it still be considered a hybrid? Or is it only if it's two different types?
Well, I think it requires two different types to become a hybrid. Because if you're using a star, then it's still, a star network essentially. But you could connect two stars with a bus segment between them. And that's where the, like this one here. So we have a bus segment in between the two networks of stars. So we are utilizing two different types of networks. I guess if you use two of the same, it would be hard to distinguish the two networks from each other. Questions so far?
So you said the bridge that connected to was the bus?
Well, it was the router and the bridge. So you had a, couple of segments that were in a straight line. So that would be the bus. And that connected the two stars together. It was just an example of it. Yes, Chris.
Would those cables that connect the routers to the bridge, would they be coaxial or Ethernet?
Depends. Now, for that particular bus, the way it's set up, if you had, if you were running like Ethernet for the actual star, you wouldn't run coaxial between the networks because coaxial is a lower technology. So that would actually create a bottleneck in your network communicating out of it. So what you may do though, instead of coax, you might do, say, Ethernet in your star and then use fiber optic for your bus to move through it, because that can move through at a much higher speed. And so you can push a lot more data through it.
Okay.
Does that make sense?
Yeah.
Okay. Any other questions?
You would use the Ethernet for your star and your coaxial for the bus?
No, you would not use coaxial for a bus because that would create a bottleneck.
Oh. So
You would probably use either Ethernet or step up in technology and use fiber optic or something along those lines. In enterprise environments, a lot of times they'll have a server room or equipment room on each floor, and they will run fiber optics between the floors to increase the speed between those connection nodes. And then they would have stars, star networks on each floor. So each floor, everything would be connected to the switch. And then the bus would be the connection going from, say, the ground floor to the top floor, where they would have fiber optics running between the floors to facilitate communication between each of them. Any other questions? All right. Here we go. Here is a kind of a visual representation of each of the topologies. If you can imagine like the bus here, this main line would be up in the drop ceiling, and then they would have individual cables dropping down to each unit as needed. You have the mesh, as we were talking about earlier, which every single unit on the network is connected to each other. The ring shows it visible, and you can see where a single point of failure can bring the entire ring down, and then the star up here. Does anybody remember the formula for calculating how many connections are required on a mesh network?
Was it n times n minus 1 divided by 2? That's what you're talking about?
That is exactly the one I am talking about. Very good. You do want to take note of that formula. I do recall I got at least one question on it. I don't know about you, Avery. Did you?
Yeah,
So yeah.
did. And I also posted this image into the chat if anyone needs it.
N times n minus 1 divided by 2, where n stands for nodes or computers, essentially. So any questions with regards? Yes, Rienzi.
Is that just for to calculate how many cables you need for a mesh network?
It's not just cables, it's connection points.
Connection for any network type or just mesh?
Well, no, that n to the times n minus 1 divided by 2, that's strictly for mesh network. That's kind of letting you know like how quickly it gets out of hand with how many connections you're going to need. I mean, could you imagine at every desk having like 45 connections? You know, you'd have to have a huge tower of RJ45 connectors just to have all those cables hooked up so that they could talk to each other. Can we think in real world where a mesh network is actually put into place pretty effectively? We use it every day.
Is it Zoom?
Zoom works on a mesh network. Think bigger.
What, cell phone? No?
Cell phones to a degree operate off of mesh network, but they operate from a wireless standard and then they go to a wired. So they're kind of connected to it. Yeah, there you go, Mark. The internet. The internet itself is a giant mesh network. It's massive. It's nearly impossible to bring down. I say nearly because you can bring down huge chunks of it with coordinated attacks, stuff like that. But for the most part, you can bring down sections of the internet and the rest of it will function. If you're sending packets from, say, me to Marvin, and a connection point between me and him goes down, there is technology in place that tells it how to reroute around those problems. Yes, Mark.
Just thinking out loud with my hands.
Got it. Got it. So the internet itself is pretty much a giant mesh network. Questions so far? All right. Types of networks by resource location, client and server. Server can be something dedicated like a email server or proxy server or something like that. And it can be something that's not necessarily dedicated like a multimedia, like your main computer in your house sharing media amongst the rest of the house. It also could be something like a network attached storage, something like that, where it's serving up resources for the rest of the house. The server is the one providing the resources. The clients are the ones utilizing the resources. Now, based off of resource location, one that we need to be aware of is called a peer-to-peer network. There is no centralized server. There is no centralized set for resources. In this scenario, at certain times, one may be the server, one may be the client, and that may change over time. Excuse me. In this particular scenario, there is no specified server. All the computers share the networking burden themselves, amongst each other. In very small networks, this works pretty good. So you don't need to invest in more expensive infrastructure and things like that. So if you have, just a small amount of users, this works out pretty good. The limit tends to be close to 10 computers. When you exceed 10, peer-to-peer networks no longer function very well. Then you may need to get a dedicated server or domain system. Questions so far? Yes, Humberto.
So in this peer-to-peer, each computer will need 2 NICs?
In this one, no. I mean, you could have a switch in the middle of them. There's just no server that they're talking to.
Okay.
Sorry, bear with me for 1 second. Yeah, so it's not about the number of connections on this particular one. This is more about the sharing of resources. So any questions with regards to this?
Yes.
Okay.
All right, so if you reach the max like 10, is it because it slows down, like getting the information from one computer to the other, or like?
Yes, it becomes harder and harder for systems to talk to each other the more computers you put on this particular network. So with the sharing of the resources. Also, managing passwords becomes a nightmare when you start getting above 10 computers. Because each user needs to have a sign into each computer. So that's 10 on 10 computers. Every 3 months, you're changing 100 passwords. For IT, that becomes rather burdensome. So, yes, Rienzi.
This looks a lot like the mesh.
To a degree, but this is by resource location, not by physical connection. So when we're talking about this right here, this is physical layout. This is physically how the computers are connected together. Now, when we get here, we are talking about logically how they're sharing resources. So how are they talking to each other? Who has what information in hand? So you do have to separate between physical topology and logical connections. Yes, Humberto.
But how they connect to each other?
They could set this up as a ring, a bus, a mesh, a star, however they want to. That's irrelevant to the fact that they don't have a server in this situation that is sharing, that all these computers are sharing the resources with. So when they save their files on their own computers. And so let's say, you know, this person is accounting, this person is sales, this person is HR, and this is the manager. They each save their own respective files on each other's computers, but in order for accounting to know how much they need to bill, you know, the customers, they need to get onto the sales department's computer to look at their files to see what was sold. So they need to have access to it and be able to see those files. So in that case, the sales computer would be the host, the accountant would be the client. So we need to get those resources from the sales computer in order to bill customers. So these are interconnected.
Would this be wired or wireless?
It could be either.
Okay.
It has nothing to do with the physical connections. It has everything to do with just how they're sharing resources.
Okay.
But could they clash, like trying to send information at the same exact time?
That would get more into the physical topologies when you're talking about clashing, and you're talking about carrier sense multiple access collision detection, which is a method they use to kind of mitigate the data clashing with each other. This is the more that they're trying to access each other's resources, that would slow it down, you know, by the access. Yes, Chris.
I think you answered this already when you answered Jimmy, but so these to connect to the internet, these would be connected to like a wireless router or something like that. One of them would be wired to a router, or
well, I mean, you could put a switch right here in the middle of them. Each of them are connected to that switch, and then you could have a router out here that they connect to that router, and then that goes out to the internet. This is my really horrible representation of the cloud.
So that, okay, this.
But the point is amongst each other, they're all sharing resources.
Okay, okay, I think that cleared it up.
Now, if I added a big old server here, and then we connect that to the star, and then all of them, instead of saving everything on their individual computers, they just save everything to the server. And so that way everybody can access and save everything to the server. Then this no longer is a peer-to-peer network.
Okay, so the presence of a server it changes the topology of it. Okay,
the logical distribution of resources, because the server itself is providing the resources to the group. In a peer-to-peer network, there is no server. You're providing the resources for each other.
Okay.
Yes, Humberto.
Yes, so if, for example, I work in human resources and want to see the sales files, I have to know how that computer organized his files. There is not for say, I don't know how to say it, an order or how everybody has to organize their files.
Yes. So each person would be responsible for organizing their own files, and they would have to grant you access to them. So it's two ways. You know, you would have to know how they're storing it. You would also have to be allowed access to see it. But we will get into file permissions and stuff at a later time. Yes, Janina.
Okay, well, you kind of just answered my question, because I was going to ask if more than one person can access a file at the same time as someone else. That wouldn't be allowed.
Well, I mean,
right?
it depends on the program, but yes.
Okay.
I've worked in systems where literally only one person could look at a file at a time. Really annoying, by the way, especially if you have files that multiple people need to access at multiple times. And if somebody like accesses that file, then goes to lunch, then everybody else is locked out of it. So it depends on what programs you're using, whether multiple people can see it. So that has nothing to do with the actual distribution of the resources, but the software you're using. So yes, Chris, you had your hand up.
Do you mean Chris M?
Yes.
Oh, I must have left it up. I didn't have another question.
You're the only Chris here today. So you can't try to slough that one off today. Sorry, man.
Oh, my bad.
All right. So let me go ahead and erase this here. Any questions with regards to peer-to-peer? This is strictly how resources are shared. We're done with physical topologies. So these are the physical topologies we need to be aware of. With the only one not represented here would be the hybrid, which could be the use of two or more. Now we're talking about resource allocation.
Could you go back one slide real quick?
I could. Basically just gives a quick representation of client server model.
Okay.
All right. Welcome to the PAN, or personal area network. Best way to think about this is within arm's reach. This is your personal network. So you can have this set up as the central node can be a computer. More often than not, the central node is our cell phones. And all the multiple Bluetooth devices, we hook up to it. So we may share resources with headphones. We may share resources with printers off of our phone. We may print to a wireless enabled printer that would put that printer within our personal area network. On your computer, it might be a Bluetooth keyboard, wireless mouse, headset, microphone, printers, and you may actually have another computer attached to it that you're sharing resources with, but it's basically considered to be within arm's reach. Interconnections tend to be short range. Bluetooth, Firewire, USB are your main connectors for your personal area network. You can utilize others, but those are the most popular. So it's one or more devices attached. Could be another computer, could be phones, printers, peripherals, video game consoles, controllers, all that kind of stuff is in a PAN, or personal area network. Questions with regards to that? So always think about this as you individually. Devices that are connected for you personally.
So personal area network, like do you mean like by your own like internet connection?
Well, at that point, you're connecting to the internet to go outside. That becomes a different type of network. But if you have your computer with your keyboard hooked up to it, mouse, touchpad, microphone, all that stuff would be in your PAN, your personal area network.
That can also involve like your car. So if you're connecting to your car's Bluetooth, your phone, and I guess your inner console would be a part of your PAN.
Yep.
So anything that's directly connected to you and your device.
Very, very oftenly questioned and on CompTIA or in question settings. When you think PAN, you're thinking Bluetooth, Luis. You're thinking how you're causing that connection, how you are the center, like the picture is showing. But when you think PAN, you need to be searching for Bluetooth because they're hand in hand.
Yeah,
I like that. Hand in hand with PAN.
There you go.
Rienzi.
Yes, that's what I was gonna ask. I think you guys kind of clarified it. So if I use my phone as a hotspot and I connect my computer and then like that, is that considered that type of network?
That's tethering, but yes two, I mean, the hotspot thing gets a little dodgy because you can connect multiple PANs to a hotspot.
Right.
So that's where you got to start, you know, like you can connect your computer with stuff connected to your computer, which would be the PAN for that computer to that hotspot. You could connect your friend's computer and their, you know, locally connected devices or Bluetooth headsets and all that stuff. Their PAN would be connected to your phone. So you're connecting PANs to your phone through that hotspot.
And you're jumping just a little bit out of the pan. I'm here all night. When you talk like that, I would rather you stick with how you are trying to support yourself. Like I got Bluetooth earphones to my phone. That's a PAN. That's a personal area network. As you see on the picture, a wireless mouse or a keyboard. It's all supporting me. When you go to hotspot, I feel like you're heightening that technology and you're getting a little bit outside of what we want you to understand with what this is. So try to temper yourself on that one. Temper it in the pan. I'm here all night, man. What'd you have, Mark? You had something? I saw your hand go up.
Yeah, I was pretty much going to say the same thing you said. Simple way to remember it is like, say you're at the library and you're studying and you playing music in the background off of your computer, but you have your headphones on. Headphones are Bluetooth connected to your computer, and you know, you just got your little area network there. And if you're at the house, maybe at the library they have a printer that you can connect to, Bluetooth connect to it to print. Simple like that.
I like it, Mark. You're the center, and as long as you know that you're the center, you feel that personal area network. So,
absolutely. All right. Let's expand our range just a little bit to the LAN or local area network. This is basically a large group of computers or a group of computers collected in a relatively small area like an office, could be in your home. I would not extend this beyond like a big building, like a large building. That would be about as far as you might go with something with this. And these devices are connected by common mediums. And they allow sharing of data and peripherals and all that kind of fun stuff, storage, software, high speed, relatively low cost. The topologies, the physical topologies we were talking about earlier, the bus, the star, and the ring are the most common that you would see with regards to local area networks. So roughly about the biggest you would go with this, about the size of a building. So
could you repeat that again about the physical topology?
Okay, the physical topologies that are most commonly seen in the LANs are the bus, the star, and the ring. Ring topology is rarely seen nowadays, although if you continue on this journey after you're done with your A+ and want to keep pushing through, in Network Plus, they will talk about SANs, which is storage as a network, and they will still on occasion utilize ring topologies. So that would still be encased inside of your local area network. Any other questions? All right. Let's expand it out just a little bit more. WLANs, or wireless local area networks. We are very, very familiar with this in our houses. And when we go out to, like if we go out to restaurants and stuff like that, and we hook up to their Wi-Fi, This is a wireless local area network. Everything is connected through Wi-Fi technology. It can be public and unsecure, or it can be private and secure, depending on how it is set up. It provides a lot of flexibility and mobility to those utilizing it. So questions. So WLAN is the wireless version of the local area network. Again, typically we not see this exceed the size of a building.
And in like a question format, it'll say like wirelessly connected when it's referring to a wireless LAN, a WLAN. Because you'll probably see this in 1 or 2 questions, either from us or on CompTIA.
Probably see it a lot more than 1 or 2 from us.
Yeah.
Say that again, Avery?
So a wireless, when a question's talking about a WLAN, it'll say that it's a wireless connection, and that's going to be your big hint that it's a WLAN versus a regular LAN.
Kind of like when we were talking about touchscreen monitors versus regular monitors. If they do not specify touchscreen, assume it is a regular monitor. And with regards to LAN versus WLAN, they will specify wireless connection. Any other questions? All right, let's expand it out just a little bit more. Wireless mesh networks. So a WLAN would be connecting to a single point. Many of us who live in an apartment or a house or whatever, if we have our wireless router or whatever on one side of the apartment or house, doesn't always reach to the other side. So what do we usually need to do at that point? Probably get a,
Repeat.
go ahead.
An Ethernet cable.
Well, that would do that. Yeah, you could do that, but you really want an Ethernet cable just running all the way through your house? I've done it. It's no fun. Another router. Yeah, you probably could do that.
Avery should share his pictures of that hotel, but
Yeah, we'll get to that in a minute.
What,
About a
move
re-
the
a
router closer to
repeater.
the device?
Yeah, you could, but I mean, what if you got like a really large area that you've got to cover? Like it's going, you know, what if you have like a shed behind your house, or you got like a mother-in-law suite out back, and you want to get wireless internet out there too? How would you facilitate that?
Would you introduce another device?
Yes, you would. And you would create what is called a wireless mesh network, or WMN. So wireless mesh network. This is where you would have a master unit that controls all the subsequent units connected to it in the network. So you would have multiple access points, or WAPs, wireless access points, and they would all kind of work together. They would have the same SSID and password. And as you are leaving the connection of one and get a better signal in the other, your device will seamlessly jump to the other device, allowing you to create a coverage area much larger than you possibly could with a single wireless LAN. So you're creating this mesh network out of multiple access points. And you're seeing mesh networks becoming more and more popular as they're advertising them through Comcast and AT&T and all that stuff. They have these devices. I think like they have Wemo and a couple others where you can set up devices all around your house, and it creates a mesh network for your house. And so it doesn't matter where you are, you can get a relatively strong signal. This is also wonderful if you have a multi-story building, because sometimes it's hard to carry that signal up into the next floor. And as Marvin pointed out, with minimum to no loss of connection speeds. So wireless, go ahead, TK.
Can you, I'm still not understanding the WLAN and the WMN. I mean,
Okay. So WLAN is a single wireless connection, single point, multiple devices connecting to it. Kind of like a star network almost. So you have that single device that's connecting to everything.
If you currently have a router in your home and you're using a notebook wirelessly, TK, you're using a wireless LAN.
Yeah. So you have a WLAN. Now,
so I get that part. Is the where the WN come in at with that?
So wireless mesh network. So you remember here we had the one router right here, or the one wireless access point.
Yeah.
If you move over to this one over here, you have 1, 2, 3, 4, 5, 6. And you can see with each one, like this one over here has a computer, a phone, and another computer connected to it. This one over here, right here, has 2 computers hooked to it. This one over here has a computer and a phone. So it is, instead of a singular device, you have multiple devices acting like one device. You're creating a mesh of connections where if you're losing connection with device A right here, which would be the controller, so you're walking away from it and you lose connection, well, it automatically hooks up to the very next one in the connection because it uses the exact same SSID, or sign in and password is the same for all of these devices. So you don't notice it, but your device automatically switches from one to the other because it has a better signal. Does that make sense, TK?
So the devices would be the router.
Yes, these got to be precise with our language. The wireless access points. A router is a very specific thing, and we will talk about that here in a little bit. So all of these are wireless access points. Now over here, this is where it gets confusing. I was mentioning this earlier. This device here is a wireless access point, a switch, a router, all in one. So it's everything in one. It makes it very difficult to kind of distinguish it. But when we were getting into mesh networks, these devices are single purpose. They are only wireless access points. I'm not sure, Avery, if you're trying to send that to just me, but that's who you send it to.
I did.
Okay.
Those are the images that you can share at your leisure.
Oh, okay. I like
you can go ahead and drop them.
Well, I didn't know if you wanted to share it on
yeah,
the big screen.
Yeah, we'll probably do that here in a minute.
Okay.
TK, are you good now? So,
yeah, I'm understanding it now.
Okay. Chris?
Got questions.
Thank
So,
you.
could you configure a router to be just a wireless access point?
Technically, yes.
Okay.
Would you want to? Maybe, maybe not, because you could probably get a much more efficient and effective wireless access point that's single use than utilizing a small home or office router and repurposing it just for a wireless access point. So that falls into there, like technically yes, but would you really want to? So, Jimmy?
So what type of device would make a better access point than a router? Would it be like one of those range extenders or what?
Well, a range extender, it basically is just, it's like a pass-through device. Now, when you're talking about an enterprise setting where you would be setting up a giant mesh network like this, they have dedicated devices. You'll see them up in the roofs of buildings where they have like those little balls that come down. It looks like somebody just glued a router to the ceiling. But they have these little wireless antennas that are like spaced out about every, 50 feet or 100 feet, something like that, throughout an entire building to get you access. So like on an enterprise level, they have dedicated devices that are very efficient at doing just that. but there is a controlling device that controls all of them. So like if you have to change your password, you change your password on the controlling device, and it pushes that password change out to all the subsequent devices so that they follow suit.
So basically the same router, and then there's like a satellite.
Well, like you have a router in an enterprise setting. This is where, you know, we're starting to diverge between what you see at your house versus what you come across in the work environment. So the router will be a big device that's like chunked into the wall. That's where incoming and outgoing connections are handled in the network. From there, you would probably hook it up to a switch. From the switch, you would hook up wireless access points to communicate with all other wireless devices that would all come back through into the network.
Now, Jimmy, at my house right now, I have fiber from AT&T. AT&T gave me a wireless gateway. So if I wanted to just use that, I should be able to get good coverage throughout my house. But towards the back of the house, it wasn't picking up. So what I did, I purchased some through Linksys. I went to Walmart and they were on sale. I'm very big at trying to find the ones that's on sale. But nevertheless, I bought some nodes to create a wireless mesh network. And what I did on that route, on that gateway that you get from your cable company, they have the ports in the back, because essentially it's a router, but it serves also as the way that you watch TV, because it has cable going through it and everything. So I plugged it up next to the gateway, and then I took because I only got 2, but I can add as many as I want. The kit came with 2, and I put the other one in the master bedroom, which was on the next level. So if I had a full mesh set network, I could use that one device to control different passwords, like Kelly was saying. But now I have AT&T, and I also have a different SSID for my wireless mesh network. And all they're like they look like little rectangular boxes. And it's one right next to the gateway, and it's one way up in the master bedroom, primary bedroom. And I can use this little app to see the strength of the range, and it doesn't fall off from anywhere in the house. I have the highest bar on the range. And if I wanted to extend it to the backyard, I would just have to buy one and put one downstairs near the back door. So that's its whole purpose. It's just to provide me with wireless internet or this networking, because I can use it for that as well. So did they help you, Jimmy?
Yeah, thanks.
Okay. You would
I had to configure it a little bit.
Yeah, their configuration is needed, because if it's going to be hooked up to a control device, it needs to know what that control device is.
And it's very simple.
Yeah, I mean, it's not a hard setup, but yes, you do need to configure these devices when you set them up.
I bought the devices. I downloaded the free app off of the App Store, and it already recognized. I just had to scan some stuff with the QR, and we're up and going in less than 10 minutes. And that will be the same for you. They try to make it as simple as possible.
Thankfully.
I got a question. So because I am interested in doing a similar thing, would you be willing to share whatever you got, whatever product you got?
I got you, man. I got you.
Well, there's other products that might actually work for you, Jimmy, depending on what you're wanting to do.
Okay, yeah, I would love to have better access to Wi-Fi in my backyard and like shed. So that's what I was thinking about.
Okay. So yeah, we can talk about that, setting up wireless mesh networks and stuff like that as well. Yes, Mark, sorry, your hand go up, sir.
Oh, you said what I was going to say too already.
Yeah, like
extending,
extending your Wi-Fi with the repeaters and the mesh networks. Those are good things. It all depends on, like how much are you willing to get into it on cost. A lot of it is a lot of times what it comes down to. One of the things I did, because where my office is located near the front of the house is the complete opposite side of the house of where my Wi-Fi router is. So I had like very poor connection between the front and the back of the house. So I ran what was called a power line, or Ethernet over power. And what it does is it essentially takes my power, the copper in my power, cables in my house, and runs data over them. And so I get the benefit of a wired connection all the way across the house versus trying to get a spotty connection through Wi-Fi. There you go. All right, any other questions? All right. Let's broaden it out a little bit more. Now we get to the MAN, or the Metropolitan Area Network. Can cover a few city blocks to a whole city, a few miles up to about tens of miles, and connect several LANs together. It's also going to be used for universities and stuff like that, where you're connecting multiple buildings together, campuses, like large campuses and stuff like that. Although they just segment that down a little bit more into Network Plus, where they call that a CAN, or campus area network. But for the purposes of this, think of it as a MAN is a metro area. So up to the size of a city. So we have the PAN, which is your personal thing within arm's reach. When we go to the LAN, about the size of a building. Now we get to the MAN, multiple buildings together within the same metro area. And it's a connection of multiple LANs. Questions with regards to a MAN? All right. Just when you thought it couldn't get any bigger, let's expand it out a little bit more. To the WAN, or Wide Area Network. So this is going into much larger geographical areas, like if you're connecting multiple cities together, if your company is operating in Florida, the Carolinas, up in, the middle, the Midwest, and then also in California or something like that, and you're connecting all these networks together, that would be a WAN, or Wide Area Network. It also could span multiple continents, like you can get over into Europe or Asia or Africa or South America, Australia. You can have these connections put together, and that would also be considered a WAN, or Wide Area Network. It can go the whole globe. They're even talking about adding a new category to this because of communications with the moon and Mars and stuff like that, where it's interplanetary. They haven't gotten that far yet. They still consider those WANs. So if we're talking to our satellites in space and then the rover on Mars, that's a WAN. So any questions with regards to that? All right, the NIC, we should be very familiar with this by now, or Network Interface Card. This is the physical connection between the computer and the network cable itself. It's rare that you will actually see a physical NIC like this. Most times it is integrated into the motherboard itself. Although they do still make these, in case the one in your motherboard goes out, you can expand into a device like this. Or if you're changing the mediums that it wasn't originally intended for, like say you're setting up your computer for fiber optic connections or something like that, you could get a fiber NIC for your computer and expand it. Now, this can boost the digital signal from the computer itself, and it could change the data stream from a wide stream to a narrow stream itself, or parallel or serial conversion. And it can move data from the RAM and manage the flow of data from the network cable itself. So it does kind of wear a couple different hats, but for the most part, it is utilized to interface with the network itself and your computer. All right. Why don't we take a 5-minute break before we jump into hexadecimals? Let everybody kind of absorb what they've gotten here a little bit. And then we will dive. MAC addresses stands for Media Access Control. Now, any device that hooks up to the network itself has a MAC address. It's built into every single NIC. Your computer likely has multiple MAC addresses depending on which NIC you're using. Now, a MAC address itself is 48 bits expressed in 12 hexadecimal characters. So you can see a kind of representation one down here. You have E0CB4E930278 broken up by colons. So you want to be able to identify on site. That's what a MAC address looks like. So, and the MAC address is broken up into 2 groups within the address itself. You have the first part of the MAC address, which is the first 3 bytes. This here identifies who the manufacturer of that device is. So by looking at these first 3 octets, you can say, I know that manufacturer is Lenovo or Apple or whatever. The last 3 bytes right here is unique to that device. So it's kind of like the social security number for that particular device itself. Yes, Evan.
So each manufacturer has its own MAC address?
Each manufacturer will utilize first 3 bytes of that MAC address will point you to it. And that could be based off a model number, because there aren't, 20,000 manufacturers of devices. So it may be for the HP 5000 series, that's the MAC address. Is these first 3 right here, 3 bytes, that would be that address. And then the last 3 again are the unique identifier of that individual device itself. Does that answer your question, Evan? All right, Jimmy.
Do we need to know for the test which 3, like which manufacturer has which numbers?
No.
Okay.
Your coworker Google can help you with that.
Okay.
But here's the threat. So you go out onto the internet, somebody gets a hold of your MAC address for your router. They know, oh, your router is made by Comcast. Oh, let me check and see if they've changed their sign-in and password on their router. So they know the owner is Costco is the manufacturer, not Costco, Comcast on C. Comcast is the manufacturer, and so you know what they would typically use for their sign-in and password for their routers. So if somebody gets a hold of that MAC address, they can use that to kind of breach your security if you haven't taken precautions. All right. And then, like we said, the last bits here, last 3 bytes, that is your personal identifier for that unique device itself. This is also known as your hardware address. your physical address, your adapter address, and your Ethernet address. Those are all synonymous with MAC address or media access control. Now, we all remember how to count from 0 to 255 in binary, right? We know binary, typically things are broken down into bytes, which is 8 bits, correct? And then we had that funky little piece of random information at the time called a nibble, which was 4 bits, right? So instead of 8, we broke it down into 4. Well, they found a more efficient way of utilizing the binary system to convey more information in a shorter period. So we now have the introduction of what is called hexadecimals. So a quick way to write this is it goes from 0 to F, or 0 to 15. Because if you know that if you only added up the first 4 bytes, remember it was it 1, 2, 4, 8, and if you turn them all on, that would give you 15, right? So you'd have 8 plus 4 plus 2 plus 1, so 15, right? So, but how do you tell the difference between and like 115 and 1 space 15? If you're doing shorthand notation, how do you tell the difference between those two? To eat up the, to clear up the confusion, we go to hexadecimals right here. So we go from 0 to 9, maintaining the normal number nomenclature for your binary, as you see up to the side. And then when we hit 10, because how would we tell the difference between 10 and 1, 0? We now go to letters. So we got A, B, C, D, E, and F. If you see anything above F, it is an invalid MAC address. If it's an IP version 6 address, if you see anything above F, it's an invalid address. It is not hexadecimal format. You need to be able to know that one on site. So we can look at.
You will be tested on that.
Yes,
pretty
you will
frequently. You will be asked that kind of question, guaranteed.
So if we take the letter E over here, how would that look in binary? That would be 1, 1, 1, 0. So this chart will kind of help you along that way. If it's easier for you to remember it, 0 through 15 based off of binary, and then just convert it over anything 10 and above to your letters. That's one way you can do it. If any of you out there have been dying to start up a Twitch channel for gaming, we have a game called Flippy Bit, which will help teach you how to become more proficient at hexadecimals. I have yet to see anybody start up a Twitch channel. I'm still hopeful. I would subscribe, and I don't even get on Twitch.
You want me to put the link in the chat, Kelly?
No, we'll get to it tomorrow when we talk about TCP/IP.
Okay.
So we will get to Flippy Bit. So, is there any confusion as to how hexadecimals are represented with regards to binary to letters? Does it? Yes, Rienzi.
Okay, so am I just to memorize this, or can I?
Well, do you remember how to do the binary?
I remember how to do the binary.
This is the same thing. So let me kill the annotation here. Oops, let me erase what I got first. Go back a page so we can't see it. So instead of 8 bits, we've only got 4, right? So give me the binary representation. So remember we have, what was it, 1, 2, 4, 8. So instead of having to go all the way to 16, we only have to go to 8, right?
Oh,
So give me the binary for 6. So what's the binary for 6?
it would be 0, 1, 1, 0.
0, 1, 1, 0,
Mhm.
right?
Mhm.
All right, what's the binary for 12?
12 would be 1, 1, 0, 0.
1, 1, 0, 0. Now we know we can't write 12.
Hmm.
So what would that be represented as in binary? Or in, excuse me, in hexadecimal. So we know it's 0 to 9, and then what do we do?
Then letters, okay.
So how would we represent 12? What is 12?
One of them letters, would be
Well,
8. B is 11. C.
C.
My heart is C.
There you go. C.
Oh,
You got it. So
mhm.
first you can do the binary counting the same exact way we were doing it with the 8, but it's only 4, so it's a little bit easier, right? It's a lot quicker.
Oh,
And then once you hit 9, you go to letters, but we only go up to 15 because there's only 4 bits. So the highest we can go is what letter?
F.
F. Very good. So if you see a G, H, I, any of that stuff in a MAC address or an IP version 6 address, I will learn to speak by the end of today, I promise. If IP version 6 address, then you know it's invalid. You can immediately discount it from your answers, immediately knock it off the podium. It is not a valid address. You should not pay it any more attention. Unless they're saying which one is not a valid address. Then that would be the first indicator that it's bad. I was wondering who the lightning was, and apparently it's me. All right. Hopefully my internet holds out. All right. Any other questions with regards to hexadecimals? Does it make more sense? So this is just a quick reference chart you can use a snippet tool, cut it out, what have you, just to kind of have it handy. Also, we're going to be giving you a Excel spreadsheet called ANDing, which will help you with the IP addresses and stuff like that, converting it from the address itself to binary and then back again. So we will give you guys a spreadsheet you can kind of play around with and utilize the tools and stuff like that. So it's a pretty nice little tool to use. And then we have the Flippy Bit game as well to kind of increase your proficiency if you want. All right.
I posted that chart in the chat for you guys.
Thank you, Avery. Moving right along to devices on a network. All of these things we'll be getting into a little bit more detail when we get into TCP/IP, SOHO routers, and network servers and stuff like that. We'll talk about these more as we go, but we're going to get pretty good information on them today. We have the switch, the bridge, the router, and then the repeater. Why would we need a repeater? Anybody think of a reason why we would need a repeater?
Because sometimes things are transmitted and there are errors, so they have to retransmit.
But if you repeat it, you're just repeating those errors, right?
Ah, okay.
So why would we do that? I like where your head's at, though, Riz. Extension. Can you please elaborate on that thought there, TJ?
Just like Mark said in the chat,
Okay.
where the signal strength is low, or where you
Okay.
feel like you want more power and the strength of the network, you can use a repeater, and then you extend it there.
I like it. Jimmy?
Yeah, so this is kind of I believe repeater is used for like kind of what me and Marvin were talking about, when the signal is weaker and you want to help that be stronger in the area that's further away from the source.
Yes, that can make sense. What if we just run a longer cable? Can't we just do that?
Isn't that just impractical, or because the length of the cable will affect performance?
Well, I mean, it would be impractical to try to run a Wi-Fi network across the ocean, wouldn't it?
True.
So cable would be about our only choice.
Very true.
So we can just make a longer cable, right? I mean, if we wanted to do it, couldn't we?
But wouldn't that be like not cost effective for certain situations?
Or is
It can be.
The distance matters, like how far it's gonna travel depending on, you know.
Precisely. Cables are rated for certain distances. Remember we were talking about USB connectors, say like this cable can get no longer than 9 meters. This cable is only good up to 3 meters. That's because if you exceed that length, you start to have what's called attenuation, or that's when the signal itself starts to break down. So you use a repeater to kind of re-up that signal. They catch it, they're able to replay it and push it back out again. So when we ran fiber optics across the entire ocean, single mode fiber can run up to, I think it's like, some of them can go as long as 40 kilometers. Well, the ocean's longer than 40 kilometers. So about every 40 kilometers, they literally had to attach a repeater to the cable and then put another cable on the other end of it so that it would repeat that signal to continue on. So every 40 kilometers across the entire ocean, they had to hook up a repeater for the fiber optics to make sure that signal strength is maintained. So that is the purpose of a repeater on your network. So if you have to go beyond the length of the network cable's capabilities, you can set something in between those two sets of cables. And it's very ominous sounds for what we're talking about too. To re-up that signal so that the strength is maintained and the signal can continue on to its destination. Now, let's get into it. Lowest level device on a network, for the most part, is the hub. The hub is a dumb device, for the most part, is what it's considered. It is a physical gathering point for cables on the NIC. It does not evaluate who is sending and who wants the information. It literally just screams it out to everybody. So if I send a signal into a hub, it sends that exact same signal out every other section of the hub. Does not discriminate based on, you know, who wants the information or who it's actually addressed to. Everybody gets the information. And then your NICs on your computer have to sort out whether or not that is actually addressed to them or not. If it's not addressed to them, it drops the signal, doesn't pay attention to it. If it's meant for them, it gives them the signal, or they'll pick up that signal. Now, the downfall of this is for each added node on a hub, it's going to decrease your speed at how much you can talk, because only one person can talk at a time on a hub. So the signal can only be transmitted by a single node at any given time. So you might be sitting there thinking, well, what happens if two people talk at the same time? There is what's called a collision. The data essentially rams into each other and it can't get through. So you have a collision. So
can I ask a question though?
Yes.
Is it because of the speed of the hub? That's why they can't handle more like more connections?
No. It's the amount of people talking on that particular device.
And it's the design of the hub, Luis. It's the way that it was built. It wasn't built to sustain that type of traffic. It's very simply made, very simple device. What you have, Pozo?
So a hub is in some way like a splitter.
I get what, yeah, I see what you're saying there. It's very similar. Is it just me or Kelly's pause?
He froze.
I think he
You
had
might
a
have
very,
lost him.
Yeah, he's frozen.
had a very good.
Okay, so again, go over this real quick. When a collision occurs, when two devices collide or talk at the same time, there is a collision. So in order to prevent this, they have what is called CSMA-CD, which stands for Carrier Sense Multiple Access. And then you have the /CD, which stands for Collision Detection. So when two devices talk at the same time, there's a collision. Both devices will now back off for some random amount of time. It's almost like they roll a dice. And then once that time is up, then they will retransmit. It is very likely that the two will roll the exact same number. But what happens is, I mean, because it's like a dice with like a million sides on it. So once they back off, then they're able to retransmit after a set amount of time. So this is where we were talking about where it didn't matter the speed of the device. It's because of this continual collision and backing off that's causing the slowdowns. And the more computers you add to the mix, the more common collisions become. So they had to implement this CSMA-CD. Easiest way to remember is just look for the CD for collision detection. It's detected a collision has occurred. Computers back for before they retransmit data. Question so far? So you had your hand up for a second there, Jimmy. Did we answer your question or no?
Well, I was just wondering when a collision occurs, isn't there a name for that? I think I remember it was, they call it a choke point from the Coursera, or am I wrong?
I don't recall it being a choke point. It's just, it's called a collision because two pieces of data essentially have rammed into each other and created a collision. Now, if you have repeated collisions in an area, that can be a choke point because it's slowing down your ability to transmit data.
Okay.
But I don't recall, you know, them calling this something different. This is specifically considered data collision.
I got something I was confused, maybe. Yeah.
Okay. Yes, Humberto.
Yes, the CSMA-CD, isn't that the standard for Ethernet?
No, I do not believe it is the standard for the internet.
I mean,
the internet is not operating off of hubs. It is very, very rare.
Ethernet.
Oh, Ethernet?
Yeah.
For hubs, yes, they utilize this, but other things have come into play, which, you know, kind of make this obsolete when you start applying other technologies. Do you have something to say, Avery? You're kind of leaning forward.
Typing.
He's just engaged. He's engaged. That's his engaged picture.
All right. So this is on hubs, and all devices hooked up to a hub are considered to all be in the same collision domain. So they would be in an area where collisions would be happening readily. Also, hubs communicate strictly on ones and zeros. It doesn't care about the data that comes in. It doesn't care whether, you know, what kind of packets it's for, who's it for, whatever. As the ones and zeros come in, it transmits the ones and zeros back out. So it operates off of the physical layer, layer one device. Seems kind of inefficient. So somebody improved upon this technology. They created switches. Switches are significantly smarter than hubs. They don't just blast the information out. The switches actually pay attention to who's sending and who should be receiving information. As soon as you hook up a computer to a switch, it takes note of your computer or your device's MAC address, media access control, social security number for your device. So now it has that MAC address. Say like, I want to send, this photo to Avery. Avery is on MAC address, what have you. The switch takes that in and goes, okay, I sent it in through port 1. It looks at it and says, okay, well, that MAC address, I know that MAC address is on port 4. So it sends the information out on port 4 and port 4 only. All other people on that switch are not bothered by the information being sent. And you can attach a whole bunch up to a switch without slowing down the speed because the collisions do not become an issue. Every single port on a switch is its own collision domain. Now, since hubs operate off of MAC addresses, they are more sophisticated than the hub itself. So MAC addresses operate off of the data link layer. So it is a layer 2 device. For the most part, switches are layer 2. There are cases for layer 3 switches. I don't think they get into that with 1001. Avery, you have to remind me because I've had a few exams since then.
I do not recall.
Okay, so they don't mention layer 3 switches.
So. I don't believe
they are a thing, but I don't think you need to know that for the exam. But what you kind of do need to be aware of is you have managed and unmanaged switches. Now, the switches you will have in your house look like this one up here, right here. That would be an example of an unmanaged switch. Doesn't require any intervention from you at all. It's literally plug and play. You hook it up, plug it in, and it just works. Beautiful thing. It starts instantly sorting all the MAC addresses that are on that system and then being able to communicate based on those MAC addresses without creating collisions within your network. When you get to the enterprise level here, it's a much larger device down on the bottom. These are typically considered managed switches. So you can actually create what are called virtual switches within this, or virtual LANs within a switch. So I could take this switch down here and I can say, these people right here, they're one network. These people over here, that's, LAN 2, LAN 1, and let's do LAN 3. So you've broken them down into 3 different groups. When is back in the day for me? I don't know.
He's talking to Diaz.
Oh, okay.
Yeah, I got to figure out.
Okay.
If TVs had that.
So here you go. So like say you have your accounting team, you could put all your accounting team on LAN 1. You could put all your salespeople on LAN 2 and all your HR people on LAN 3. They would operate as if they were on the same switch together. So like you have all the accounting people on LAN 1, they would operate as if they're on the same switch. They could all talk to each other, but they can't see the people on LAN 2 in sales. So they don't have the access to the sales team the same as they do the accounting team. They're able to break this up into smaller networks to where people can see each other and operate as if they're on the same switch. The beauty part of this is you can manage this across multiple switches. So I could be in a physically different location, kind of like I am now, but from Avery and Marvin, but we can operate as if we're on the same team on the same switch. And that is created through utilizing virtual LANs and managed switches. We will get into that a little bit more. This is just kind of a preview to it. All right. Clear the board on that. Questions with regards to switches? Yes, Luis.
It's sort of related to the topic, but like, why do we have modems now? Like, we used to have like routers only. Like back then, I used to have a router only. Now that I upgraded, I have a modem now. So I have like a router and a modem.
Are you
So,
sure
like,
the device you have is actually a modem?
Yeah, I have it in my Spectrum map. It literally shows me my equipment. It identifies it each, like, and like it labels them. And I can turn it off, and turn it on like with my command. So I'm like, I'm so confused by it. Like I don't understand why like they gave another like equipment.
Another device on top of it. Well, it
Yeah.
depends on the type of
I know.
medium you have, and
I
it could
know.
be a transfer from one medium to another, and that's where the problem is.
Or can you hear me?
Optimum.
Can you hear me?
Yeah, we can hear you. We're just
Okay.
ignoring you.
And that's the worst. Hear me. But no, think about it, Luis. Who are you with? What's the company that you're with?
Spectrum.
Spectrum. Guess what Spectrum want to do? Spectrum wants you to get cable, internet, and what else from them?
I mean, they want me to buy
They
their
want you to-
like mobile.
They want you to get a
stuff,
phone
so-
line, right?
Yeah.
Uh-huh.
So that's where that modem comes in, because it's an all-in-one device. They want you to get that bundle so they can, if you late on your phone or if you late on any part of it, they can shut you all the way down. So when you bundle stuff, it can get sketchy if you don't pay it. But that's why you have a modem now. Because back then that wasn't a big thing. But I drive my price down if you go with your cable TV, your internet, and you throw in that phone and that you'll never use. You know what I'm saying? But that is there for that bundle price. That's why you see that modem.
Gotcha.
You feeling me? All right. Come on, you got to throw the cable stuff to me, Kelly. You know, I worked there for a month. I had a truck and everything, guys. Carried that ladder up a hill one time and knew it. It wasn't for me. Live and learn that. Yeah, I
is
learned
true.
about all my jobs. So
That is funny. All right. So questions with regards to switches. Layer 2 device routes data through MAC addresses on the network, smarter than hubs. You don't have to worry about collisions with regards to a switch. All right. Bridges. It allows you to essentially connect two physically dissimilar networks together. Like creating between a wired Ethernet and a wireless Ethernet, or changing from fiber optic to Ethernet. So it allows for a change of medium. Relatively simple devices in that sense. Then we get to gateways, which are routers. And they're essentially allow you to have connections between two logically dissimilar networks. So it could be between your workstations and your web servers. It could be between your internal network and the external network on the internet. So the router handles these communications between these dissimilar networks. that are logically dissimilar. And it can connect multiple networks together. And you may not just have routers on the edges of your networks. You may have routers internally connecting just, multiple networks within your company together. So you may have a star network on the first floor. You may have storage as a network running on fiber optic on the second floor. And so the router would need to connect these two separate networks together so that they can still function. But then you can have that also connected to an exterior router, which would then communicate between the outside world or internet and your internal networks. Gateways or routers operate off of layer 3. Can anybody guess what they use as far as knowing who they're talking to?
IP.
IP addresses. So based off of IP addresses, it knows where to direct these things so they can get to the right people. Am I just directing it to another network internally, or am I directing it out into the internet? Can a router be both what?
Both a bridge or a gateway.
A router a router and a gateway are pretty much the same thing. A bridge, you could kind of use a router for it, but bridges also can be very specific devices. Bridges used essentially to change mediums.
Bridge,
So like
think physical differences. Gateways, think logically differences. So bridges are physical, gateways are logical.
Yeah, bridges can change from coax to Ethernet, Ethernet to fiber. So the bridge changes the physical medium by which you're communicating, and the router connects logically different networks together.
Y'all want to have some fun?
We're already having loads of fun, man. Come on.
A bridge.
Logically dissimilar network was connecting what to the internet? Your home.
Look, it could be like connecting your internal network to the external network, which is the internet. So you would need a router in order to facilitate that connection, because they're logically dissimilar.
If you think bridge, you can think the actual bridge. It's connecting two land masses together because of the water. That's physical, two physical pieces together. That's how that's physical, if you want to remember it that way.
Okay. Go ahead, Humberto.
So a bridge is a layer 3 or layer 2?
Bridge is layer 3, if I'm not mistaken.
Nice, Alan.
All right. Any questions with regards to this? So layer 3 devices, they communicate through IP addresses. That is their main method for routing, who it's supposed to go to, where it came from, and who it goes to. When information comes into a router, all it looks at, it's like a post office. All it looks at is where did it come from, where's it going, and it forwards it on. All right. So operates specifically on the router, operates based off of logical network addresses or IP addresses. It routes packets between sub networks. And it allows home users to share cable or DSL internet. Here is an example of one that you might see in a house, although I understand this is an aged picture. They do look rather different now, but in an enterprise setting, it will look something like this device up here, and it still looks pretty similar to that to this day. They have both wired and wireless models for routers. Yes, Luis.
This is from some advice you can give me. My internet is very slow.
Mhm.
So what would be a way that I can boost the speed a bit, because I'm very far from my router, so I'm just trying to figure out a way where I can just extend the connection so I can have a
Is it a
better
wired connection or a wireless connection to your computer?
wireless.
I would try to get some form of wired connection. I was just mentioning earlier, I use Ethernet over power, where I'm using my copper power lines in my house to run data over them. And that can be very fast. I get 300 megs a second just over my power lines.
Also depends on what price you're paying and how much your subscriber has said that they will offer you as well, Luis. I know it's gonna be a drop off because it's wireless, but also it's the package. Some people are offering up to a gig. That may not ever happen, but if you're not even on that package, then you won't reap the benefits of it either. But Kelly's right. Wired over anything.
Yeah, wired is your fastest connection. And with your internet provider, with like the speeds that they're offering you, you could at best get 80% of that. That is absolute optimal conditions, wired, hooked right up to the router during off-peak time.
And if you got big money like Marvin, you can get fiber.
Yeah.
It was offered in it. I'm on a what you call that, introductory new off. Cut it out, Avery.
See,
cut it out. First, cut it out. Second, go for it, Kelly.
Those of us who live on the west side can't afford fiber.
Second,
AT&T came through our neighborhood and said, "Hey, we're going to be installing fiber in 3 months. Would you be interested?" I'm like, "Yeah, I'd absolutely be interested." We're going on 6 years now that happened, and we still haven't seen fiber.
Because they got to pay the money to get it all laid out. So there's a cost. There's an upfront cost as well, right, Kelly?
Yes. Fiber optics, very expensive to lay.
Yeah.
And goodness help you if you break one.
Yeah, that's a cost to incur there. What we want to do one day, we're going to get you guys to go to a website to see what your numbers are, wireless and wired, and compare. That'll be a good like a good project that's off the books, on the books, and we'll compare our numbers together and see what you can do to possibly increase it, decrease it, or what's playing a role or a factor in that. So Jordan, that kind of goes for you. I saw what you said. So let's see what we can do there to try to help out, because you also got to keep in mind,
Marvin, you're just trying to flex.
Yeah, I'm gonna show you. My numbers are high. I'm not gonna lie. They're kind of high. But no, I really want to do this because you got to realize, look what we're doing right now. We're eating up a lot of your bandwidth on Zoom. There's a lot that's going, and then everybody is on Zoom, but a lot of kids are going back to school now. But for one period of time, your big box company, Comcast, Xfinity, AT&T, a lot of their utilization is being used for these virtual environments for meetings. It's going to affect your speed. There's no way around it. They can try to promise you, but think about the times that you'll want it to be fast is during the day, and that's when a lot of people are using it because they're not doing that commute anymore. So there's a lot of variables that play into this. I just wanted to put that out there and let Kelly get a drink of water.
Appreciate that.
Hey, you're next, Avery.
You know, I like to make people think it was the power that went out, but I just needed a break. So I just took my 5 minutes.
You could have told us.
Hey, more dramatic that way if I cut it off.
It was very dramatic. It was very dramatic because it looked like you was about to make a point. You had your hand up and everything.
All right, don't forget, very important.
Yeah.
We heard thunder and everything. It was.
Drop the.
I just have my kids playing with pans in the kitchen. You guys just think it's thunder.
It's just the guy wobbling that aluminum in the background.
Yeah. That's funny.
Things we do to get a break. All right. Devices on a network continued. Firewalls. Be your best friend or your worst enemy. Now, this is a network security appliance, and it can either be software, as we talked about with the Windows Defender firewall, or an actual physical hardware device. Now, if it is software, it is based on each individual computer on the network. So you would have to have each individual computer have its own firewall as a form of protection for it. If it's hardware, this is going to be on the edge of your network typically, although they do sometimes have internal firewalls. And it will have multiple ways you can interface with it and varying levels of security. And it is significantly better than a software firewall overall. Now, something you will hear Marvin, myself, and Avery say quite often with regards to security, you need to find that balance between convenience and security. The greater you increase one, the lower the other becomes. There's no such thing as an extremely secure, convenient network. Just doesn't happen. Uh-oh, what did I do? Okay, there we go. Now, you have two types of firewalls in general. You have what is called a stateful firewall, which is paying attention to the state of the conversation that you are having. It will not allow a conversation to begin from outside your network. So if Marvin tried to talk to my computer first, my computer or my firewall would shut him down instantly and would not allow that conversation to take place. Now, if I originally reach out to Marvin and then he responds by sending me stuff, it will allow that conversation to continue. It's paying attention to the state of the conversation or the connection that you have. This is one of the simplest ways a firewall can be set up. This is typically how your Windows Defender firewall is set up. You base it off of varying levels of security, like low, medium, high. So that is a stateful firewall. The other way we have is a stateless firewall or packet filtering firewall. It is going to inspect all the traffic that passes across that line. It's going to examine each individual packet and then compare that against your ACL or access control list to determine whether or not that information should be allowed to pass. There are two different types of ACL rules you can utilize. You have what is called a whitelist, which means these are all the systems that are allowed. And if you're not on this list, it's automatically blocked. So whitelist means everything that's on this list is accepted, anything else is not. And then you have what's called a blacklist, which means everything is permitted unless it's on this list. So packet filtering firewalls are much slower than your stateful firewalls because they have to pay attention to a lot more information that's coming through the system itself. And then more often than not, you will see companies use blacklists rather than whitelists because whitelists have to be exceedingly comprehensive to be effective, because as things change on a daily basis, other resources come available for your employees or something along those lines, then you have to add each one of these individual things to the list so that the firewall doesn't shut it down. Blacklists, on the other hand, you're searching for things that are harmful or you do not want your employees having access to, and you just only add those to that list, and then pretty much everything else is permitted. You can do it based on like genre of material, like you don't want your employees having access to gambling sites or something like that. And so if it comes up with that type of site, it can go ahead and block it. It doesn't have to be each individual site, just a type of material. You could say like, I don't want them accessing streaming music because that chews up a lot of bandwidth in our network, and we need to preserve that network so that we can function in operations. I think Diego at one point was telling a story when he was working for UPS. The entire network in Brazil went down in one day, and they couldn't figure out what was going on at first, but then they realized that almost everybody in Brazil was watching the World Cup. So every desk they had in the background, they were streaming World Cup, and it was just so much bandwidth being chewed up by this, it literally brought the entire network to its knees. So that's where ACLs come into place, or access control lists. And then stateful, as we were talking about, pays attention to the state of the conversation, and that conversation must originate from behind the firewall. So if I'm reaching out to the network, I have to start the conversation with Marvin. If Marvin tries to start it with me, my firewall is going to block it right off the bat. Questions?
Rude. That's just rude.
Don't worry, I do it to Avery too. All right. All right, changing gears. Now I want to talk about coaxial cable. Talked about the connectors. Now we got to talk about the cables themselves. Coaxial cable itself is composed of an inner insulated conductor, this copper wire right here, surrounded by another conductor made of a metallic foil, which is right here, this braided shield. In between the two, you have this dielectric core, which kind of prevents crosstalk between those two things from occurring. It is resistant to EMI, or electromagnetic interference, partially because of this braided shielding that is underneath the jacket itself. Resistant,
But
not
it's not
immune.
Yep. Kelly, you're on the same page.
So it's kind of like when they say your watch is water resistant, does not mean it is waterproof.
Yep. And there will be questions where it'll say, which of these is immune to EMI?
Yes, there is a strong difference between immune and resistant.
Yep. And young, dumb Avery said, oh, that's coaxial. It's not.
But you learn from your mistakes.
Learn from your mistakes.
Now, we do have three main types of coaxial cable that we will be dealing with. Most common, you will see, the kind that we typically work with, are the RJ59 and the RJ58. RJ58 is kind of the old school cable ones that you would use on your TV. They have kind of improved these a little bit, and they came up to the RG59, which is used for short distance applications. This would be like from your wall to your cable modem, you know, something along those lines, or from the cable modem to a TV, if you're hooking it up to a TV box or something like that. So RJ58, RJ59, those would be the ones you would use in your house, determining which one is the most recent, higher number. RJ59 is the most recent iteration. Long hauls between networks is the RG6, thick cable for long hauls. This tends to trip people up because they assume the larger number, the thicker the cable. So the larger numbers would be the ones that they use in between the cable company and my house. No, you have to think of it in terms of wire gauges. The lower the gauge, the thicker the wire. Any questions with regards to coaxial cable? Three types: RG, 58, 59, and RG6. Back to these fun connectors we talk about here every now and again. You have the BNC right here, which you can see you have the two posts that would push in and then twist and lock. This is typically what you would see based off of Ethernets in offices and things like that, is because they're able to be quickly disconnected. And then you have the kind you would typically see for cable TV, which is the F-type connector, which has the threaded screw because it's going to be more of a permanent fixture. Any questions with regards to that? We are now experts on coaxial cable. We don't need the 2-week orientation that Marvin got before he got his cable truck.
2 week. I had 2-day ride along, and then I got my truck, man. Had my truck within the week. I was a fast learner.
Well, there you go.
So the RG59 is the one that we use for what exactly?
RG59 is the most updated technology. It's the most recent. So it will have the fastest data transmission speeds, but that is something you would use for short runs, like from your wall to the cable modem, from the cable modem to the TV box. So it'll be short runs.
And the 58 is for usually for like TVs back then.
It's an older technology, yes. So it'd be for TVs and stuff like that. But think of both of those inside the house, the RG8 external long runs for your cable company.
RG6.
RG6, yeah. All right.
And you said, Kelly, that the lower the number is the thicker wire?
Yes. With gauges. So
do we have anybody that here that did any car audio? Anybody bought subs for their car? If you notice that power wire from the battery to the amp had to be the thickest wire, but the RCAs, the wires from the amp to the back of the radio was thinner. So that thicker, the lower the number, the thicker the gauge. So they have 0 gauge wire, and that's about the size of your pinky, as far as how, like, it's super thick. It's very to allow for higher transmission of power energy. So,
and it's a common practice depending on what you're dealing with. Like they do it with piercings. If anybody's into that.
That too.
For shells, for guns and stuff like that, they deal in gauges as well. Smaller the number, the bigger the gauge. Things like that. So it's seen across multiple mediums. There you go, Jimmy. Cabling for workout machines, absolutely. All right. Now we move on to most common mediums, which would be our twisted pair groupings. First one we will talk about is the STP, or shielded twisted pair. See this metal foil right here running outside of the cable? That is shielding it from to try to avoid electromagnetic interference. Also, you will see this little piece sticking out here. This is a piece of Kevlar string. You don't really need to know that, but if you're working with the network cables, that will kind of let you know exactly what that is. But yeah, so it has the 8 twisted pairs grouped together, and then it's covered in foil. Some of them will cover each grouping. So you'll have 4 runs of foil, and then you'll have the foil around the outside. And there is varying quality with regards to shielded twisted pair. Questions so far? All right. This is the most common because for the most part, it is the least expensive. And this is the UTP, or unshielded twisted pair. So you have STP, which is shielded twisted pair, UTP, which is unshielded twisted pair. It's very similar to the last one, except there is no foil to kind of protect it from the electromagnetic interference, or EMI. This is predominantly what you will see in households and many offices and stuff like that. This STP is a more expensive cable, and you'll usually see it in industrial settings. Does anybody know why they twist the wires together like that?
Besides, it looks cool.
I know, right? It actually has to do with the signal. Oh, who was in it? Go ahead, Randy.
I was gonna say for fast, for the signal to travel fast.
It helps with the speed. It helps with the signal strength, and it prevents crosstalk. So crosstalk is when, you know, the signal jumps from one wire to another. Now, when you twist the wires together like this, they're always at a 90-degree angle from each other. So it prevents that crosstalk from happening. The more twists per inch you can get, the more secure the cable is from crosstalk. Yeah, nice, Alan. From occurring. So that is why they twist the wire pairs together. All right. I know we were just sitting there thinking, man, I want to know more about Ethernet cables. It's just such a fascinating subject. So I'm sure you've heard them call Cat 3, Cat 4, Cat 5, all that kind of fun stuff. That is the category, is what CAT is short for. And this is with regards to the generations or the technology that's being put into place with them. We do need to know the data rates at which they can run and the maximum length of the cable, because this does change. I believe Cat 5 is incorrect on its length of cable, though. For the most part, you'll get 100 meters. Cat 5 and Cat 6, I do believe you do not get 100 meters out of them, because Cat 5E is 5 extended.
You can get 100 meters.
Out of Cat 5?
Mm-hmm.
What about 6?
100 meters. That's
Where's
what,
the
that's what Google says.
Well, if there's one thing we've learned in this class, you can't trust Google. I will double check that in my network book because they do talk about that. So yes, but as the categories go higher, our transmission speeds go much faster. It does grow kind of exponentially. So you do want to be aware of that. Category 7 has not really been adopted yet, and that is a shielded medium at this point. Yes, Avery.
Are you talking about, so in the Cat 6 and 6A, it's saying 10 gig Ethernet at 55 meters?
Yes.
So are you talking about that as being
In order
the
to get
max
those
length?
speeds, you have to have the shorter speed, the shorter
Okay.
lengths.
But you can
Run it.
you can run it up
You just
to
lose
100
those
meters.
speeds.
There you
Yep.
go. I think that's the information that it's showing, and that's where the drop off. So I caught what you did, Avery, and I think you see it now, Kelly. That's the caveat that.
Yeah, I see it.
Oh,
For
yeah.
maximum speed.
Yeah.
Yes, Rienzi.
Why does it look like Cat 6 and 6A look like they have the same capabilities for?
And that's where the debate was with 6. I believe it was 55 meters, and then when they went to 6A, it was 100. I'll need to double check this data from my network book. I do have a slide deck from my Network Plus that I gave the last class. I'll give it to this class with regards to the various different types of cables and stuff like that, which helps out with studying. So that is the difference between 6 and 6A, I believe, is the length of cable that is allowed because they maintain the same speeds. Between 5 and 5E, you actually see a jump in speed. But we will add this graphic as well. Our good friends from our connectors technical session. We have our RJ45, which is the 8-pin connector. You can see down here, it has 8 wires and 8 little pins that go into it. Although, depending on the category you're using, it may not use all 8 wires. It may only use 4. And then you have the old POTS line RJ11, which has either 2 or 4 pin connectors predominantly used for telephone. Questions so far? And I know what you're saying. I know what you're thinking. We haven't learned everything we can learn about twisted pair. What more information can we have to add to our mental database on this? Well, we get to add the wiring standards. How they line up the wires in each one of these systems. There are 2 main standards utilized throughout the industry. You have the T568A and the T568B. As you'll notice, it's just not the oranges, the greens, the blues, and the browns together. They actually are separated a bit, and they utilize different patterns. We do have a mnemonic to help you remember the orders. 568B is the most common. And if you look at it, you got brown to the ground, which is the brown wires going to the ground. You got sun to the sky, the orange ones, the orange cables go to the sky. And then you have the river running between the trees.
I said that this morning.
Yep. So the orange to the sky, brown to the ground, and the river running between the trees. And it always goes stripe solid, stripe solid, stripe solid, stripe solid. Even when you look at the other one, stripe solid, stripe solid, stripe solid, stripe solid.
Kelly does this for his morning meditation. Sun to the sky.
Absolutely.
Ground.
That's how I remember this stuff. And then you have the T568A, which is not as widely recognized. It was like trees to the sky, brown to the ground, and the river runs between the valley or something like that, something along those lines. Yes, Jimmy.
So why is the A wiring the preferred?
You mean the B? I believe it is because I think it has something to do with the I believe the blue wires had more twists, or the
So
one of the wires had more twists per inch.
am I confused? Is T56AA wiring pattern is recognized as preferred?
It's, yeah, but everywhere I've ever been and what I've always been told was B was the most used.
Okay.
So A, it may just be that the people doing the wiring, that is the one they prefer.
Okay.
The one on the bottom, I think it was trees to the sky, brown to the ground, and the river runs between the valley or the sun, something like that.
I think it's Valley.
Valley.
But so the best way that I found for remembering these, you pick one that you want to memorize to heart. So if mine is B, I remember my sun to the sky, brown to the ground, and the river runs through the trees. So a big rule, it's always going to go white, solid, white, solid, white, solid, white, solid for both standards. So you know that you're at least going in semi-correct order. If you have your white and your color, then you're just solid color, your white and your color, solid color. The blue and the brown are going to stay the same for both standards.
Yeah, they
so you know
change.
That you're going to have solid blue, white blue, whatever solid color.
Okay.
White,
So,
brown, brown.
with regards to the test standards, they don't change. That's different now because we use all 8 wires now, but that's, you don't need to worry about that. It's real life versus the test. Sorry about that, Avery. Go ahead.
You're good. So your B's are going to stay the same. So if you can just remember one of the standards, you can figure out the other one by just flipping your two non-B colors.
And your green and your orange.
Yep. So I always memorized B because I like the sun to the sky. That makes a lot of sense to me. Brown, ground, and then river running through the trees.
Excuse me, Avery. Y'all have just confused me. Can you just not just say what color go to what color, and then we can put the trees and the sun and all that stuff with it?
Sure. So orange. So where the standard for B is going to be orange, white, orange, green, white, blue, blue, white, green, brown, white, brown. So your orange is your sun. Your green is your trees. The blue is your water. And the brown is the ground. And it's always going to go white color, solid, white color, solid, white color, solid, white color, solid. And
We'll
if
give you
you,
ample time to practice this.
yeah,
Yeah.
you know, for how I memorized it, like every morning for about a week, I just wrote out my standard. So white, orange, orange, white, green, blue, green, white, brown, brown. And I would just do that every morning. And then eventually it sticks with you.
There's a couple things you'll do that with. This is one of them. Ports, wireless standards, laser printing steps. So there's a few things you'll RAID arrays are all good ones to do that with.
Yeah,
So
I'm more
any,
confused now.
you what?
I feel like I'm more confused now. I don't.
It's super confusing the very first time you see it. You will
It
get more
becomes a
comfortable
lot
with it.
easier. You will get a lot
Yeah.
more comfortable with it. It's just
Yeah,
it's the first
don't
time you're
stress it.
seeing it.
I simplified as B is orange and A is green. So, you know, the first color of B is orange and the first color of A is green.
Yeah. Once you got, it's almost one of those things where it's not, there's no, the science isn't there. You just got to remember, memorize it, and you got to force yourself to memorize it. So I like how you got a good start there, Luis, with just having that as your foundation and then going from there. At least you know what it starts with. So Jimmy, before we get too far away, what you got?
So for testing purposes, do we need to just be able to identify these from one another, or do we need to be able to list like the actual order of each one?
You will possibly have to do the order.
I had to do the order on my test.
Okay, so Avery, question: when you were doing your memorizing, why are you saying white, like white, orange, or
because the stripe on it?
Yeah,
there's a white stripe. It's orange and white striped.
Okay, so you're saying
it's solid.
So you're saying white, orange, as if that's your first line.
Right.
Yeah.
White orange is referring to the cable, not white and then orange. It's like white orange. Yeah.
Okay.
So I know how that's confusing.
Yeah.
I should have clarified. Good question.
And then if you look at it, this is the back of it. The little tab here is on the other side. So you're looking behind it. You're looking at the bottom of the network connector based on how this is.
So the tab is the front.
Well, the tab would be like at the top, and we're looking at the bottom of it. So you can see like how it's dotted right here. That means it's on the other side of this. So the tab, we're looking at the bottom of the cable itself, and that's how we're seeing it. If you have a network cable laying around your house, they usually have clear heads. You can kind of look at the bottom of it. You can see how it's laid out. So, all right, we will get reviews of this here though. All right, here's the mnemonic we were just talking about. trees to the sky. So you have the green ones up top, brown to the ground, brown to the bottom here. And the river runs on a sunny day. So the river runs between, the blue runs between the orange. Then you have the B, which is sun to the sky, brown to the ground, and the river runs between the trees. So the blue goes between the green. Then you have the orange at the top and the brown at the bottom. If it makes it easier for you, it's a mnemonic that they use. All right. Continuing on. Plenum cable. I can't tell you how much CompTIA loves plenum cables.
It's their favorite.
It is their
cable.
absolute and utter favorite cable to talk about. So plenum cables, normal cables are sheathed in a PVC coating, which if fire occurs and you light PVC and it catches fire, it lets off very toxic chemicals, toxic gas that can actually be very harmful, if not fatal, to those who inhale it. So in drop ceilings and when they run cables through HVA systems, because they will do that to save time, they will use a plenum cable itself. So if it does happen to catch fire, it is one, fire retardant, so it takes a very high temperature to set it on fire. Two, if it does burn, it doesn't send a noxious gas throughout the entire system itself. So if ever you hear about drop ceilings, like you want to run a cable through a drop ceiling in an office or through an HVA system or something like that, where the air circulation is, plenum cable is your answer. It is fire retardant, and if it does catch fire, it does not release noxious gases. Questions with regards to plenum?
Guaranteed test question.
Yeah, guaranteed. If
Should
not
be a
multiple.
guaranteed free point for yourself.
Yeah. So guaranteed free, free point if you remember plenum. All right. So now you're wondering, okay, well, we've learned about coaxial, we've learned about twisted pairs. What else can we learn about? Get into fiber optics. Fiber optics uses light instead of electricity to transmit information across the lines, thereby making it completely immune to electrical magnetic interference. And we're talking about that resistance versus immunity. Fiber optics are not affected by EMI at all. It is light that is injected into the cable either through a laser or an LED.
Hey, quick question, Callie.
Yes.
Should one look into a fiber optic cable?
Not if you cherish your retinas. It doesn't matter if you can see the light or not. Don't ever point a fiber optic line towards your eyes. Shine it on a piece of paper or your hand or something along those lines. Never point it at your eyes.
That's why Marvin can only see out of one.
Yeah, there you go.
I thought it was a puppy dog in there. That's what they told me.
It can carry data over longer distances, and it can carry much larger amounts of data at a given time as well. You have two different types of fiber optics that you will be dealing with. There is multi-mode, which allows for high speed at medium distances. And then you have single mode, which gives you higher speed at longer distances. Kind of break it down like this. Multi-mode up top, they can use different colors of lasers or LEDs to transmit down the fiber optic cable, and it will bounce around inside, allowing for multiple data streams to happen at the same time. And this is great, but it cannot be continued over long distances. It is a medium range system, but allows for pretty high throughput. Single mode right here uses a single laser to transmit the data through the line. It does not bounce it around. It does not use multiple colored lasers. So it is able to transmit over a much longer distance. Questions with regards to multi-mode versus single mode?
Is that the reason why it's more expensive?
Part of it is because it has these very fine optical cores that you have to be careful not to break, bend too far, things like that. So they're expensive to make. Not to mention our infrastructure has not been installed yet with this. It's being worked on, but currently we were able to kind of piggyback on the old RG6 cables and run data over that. So we were kind of piggybacking on older infrastructure, just utilizing it in a different manner. This is a totally new technology with regards to that. And so that infrastructure has to be put in place. So yes, significantly more expensive. Now, fiber optics, if anybody who's ever been in construction, I don't know if anybody's ever been in a case where they were around when a fiber optic line got broken. About 15, close to 20 years ago, I was on site at a place when I was in college, and they broke a fiber optic line. The cost was $2,000 a minute until it was repaired. So when you call a fiber optic repair company and they say, hey, it'll be $300-400 an hour with a, $800 minimum starting from when I leave the office, not when I get there, are you going to be accepting of that charge? Yeah, because you're paying $2,000 a minute. So fiber optic repair, they charge a lot of money because they know you'll pay it. So fiber optic lines, when they get cut, it is extremely expensive because it is not easy to repair them. You can't just take the two ends and stick them together and everything's good. There's a lot more involved. You have to polish the lenses, everything. You have to use certain epoxies. It is a involved process to getting it done. And typically, if somebody has laid that data line, they laid it for a reason, and you essentially cut them off. So in that price point was from 20 years ago. So imagine what it is today. I don't think it went down. All right. So here's your fiber optic types and details. We have our multi-mode, which is the Ethernet standard, 11 base FX, 11 base or 1000 base SX, and 10G base SR. Easiest way to read these numbers, this number at the beginning right here, so 100, this 1000, 10G, that's the amount of gigabits that can be transmitted per second. So notice that this is 100 megabits per second, 1000 megabits per second, 10G, 10 gigabits per second. So that's the easiest way to remember your speeds, quickest way to reference it. Now, over here, single mode is considered long haul. So the L's, the LX, and the LR are your long hauls. And then you have the SXs, SR, and FX for your short hauls. So the S's are for your short hauls, and then FX you just have to remember. And then your distances, 2 kilometers is your maximum you can get out of multi-mode, 10 kilometers out of a single mode. Questions so far? Right. Fiber optic connectors. there are 4 that we really need to pay attention to. You got the straight tip right here, has a round connection head, and it has a protruding part of the fiber optic sticking out of it, and it utilizes the old BMC connector, the bayonet Neil Councilman, same type of connector sitting on the end of it. You can see it right here where the T would go in, twist, and lock. So that would be considered a straight tip. So you have the straight piece coming out of it, used predominantly with multi-mode fiber. You have your square connector. It has a square face on it, so that's one of the easiest ones to remember. So SC, or square connector. Then you have the LC, or Lucent connector. The little tab sticking up out of here makes a, kind of an L to kind of help you remember it. It does have a smaller, a square shaped connector on it, but that tab is going to be your indicator that it is an LC or Lucent connector, because the tab makes an L shape. Then the outlier of the group, the MTRJ, has 2 fiber optics in a single connector, making it easy to identify. And it is also the small form factor of the group. It is a very, very small footprint for the MTRJ.
I always would remember this one by thinking of MT as multi, and there are 2 connectors, or 2 strands. So multi 2.
Like it. We're almost there. Hang in there. Now we got to wake everybody up. Go to the sticks. Chris, what is number 1, please?
Square connector.
Square connector. Very good. TJ, what is number 2, please? Please be specific.
I know it's a coaxial cable.
Okay. Very good. What kind of connector does it have on it?
Yeah, I don't know.
You want to phone a friend?
Yeah.
All right. Who do you want to ask?
Jimmy has his hand up.
Go ahead, Jim. Well, you can't take it back now, man. You got your hand up.
Unmute.
You're
Unmute,
muted.
Jimmy.
You're muted.
Oh, okay. Good thing I was muted, because I was gonna say RJ45, but I changed it to RJ11.
For
Hold
number
on.
2?
You gotta look down. 2 is
You're
down,
looking
not
at 3.
across.
Oh no, I don't know
He said
that.
he said it was a coax, but I asked what kind of connector.
Oof,
PNC.
the connector. I don't know number 2. I was looking at number 3. Sorry.
Yeah. Luis helped you out.
Now I'm on the hook.
There's only 2 types of connectors for a coax, right? What are they?
Guys, NC connector. I forget the initials. Gee, I
Getting
can't.
some help in the chat, just so you know.
Oh, is it a BNC connector?
BNC connector, bayonet Neil Councilman.
Okay.
So BNC, that's that T, that twist and lock connector.
Okay.
Not to be confused with the F type, which is like the threaded screw that we would see like typical on TVs and cable boxes and stuff.
Okay.
Not bad. Not bad. I know it's the first time you guys are seeing this stuff, so
Go ahead and give Jimmy number 3, Kelly, since he was so amped about answering that one. Go ahead and answer that one.
What's number 3 there, Jimmy?
So that's the RJ11.
How do you know?
I remember RJ45 is the thick Ethernet, and
Okay.
then RJ11 is the 4-pin.
Okay. Okay. We will give it to you. Very good. Number 4. This is the one in the bottom center. Jordan. It's number 4. Right here.
Would it be the fiber optic cable?
That is fiber optic, but we need to be a little more specific.
The single mode?
Well, this one actually would go with a multi-mode. What kind of connector is that?
I'm not sure.
Not to be confused with number 1, which is square. Check out the chat. Chat always help you out. You still up, Jordan? You got to finish this, man.
Straight.
There you go.
Straight tip. It has the protruding tip sticking out of it. Still uses the BNC connector. This is a multi-mode, not to be confused. So ST, not to be confused with SC, which is the square connector right here with the square box around it. Right. See, Kaylin, can you give us number 5, please? Right here. You are correct, Kaylin. Lucient connector makes that nice little L with the tab right there. See a little L? So good job. Finally, we have Renee. Can you give us number 6, please? Okay. Aijan, can you give us number 6, please? Right here.
It's, I think it's RG45.
I think you are correct. Very good. So RJ45. Very well done. All right. Lastly, we'll just quickly touch base. We went over this. We were talking about our intro to computers. We were kind of going through it. When you're making your Ethernet cables, if you're making them yourselves, you will typically use right here a crimper that can do, this one here can do RJ45 in this hole, and it can do RJ11 in this one. So once you have placed your wires and threaded them properly, then you would crimp down the connector head so that it is firmly secured to the wires at that point. Also drives the copper connectors into the wires. They pierce the wires so that the connector itself can function. On the other side of the coin, like for the receptacles in the walls and at the punch down blocks in the server room, you would use a tool like this, the 128 for the 128 blocks. You have a punch down tool. This is like, it looks like a little U here. It's got a flat piece on one side and then a knife edge on the other. And it will push down the cable into the connector so that it's pierced and actually cut the end of the cable off, the excess. So you need to be careful that you have it pointed in the right direction so you don't cut off the wrong side of the cable. So this is kind of a description of it here. You can see the punch down tool where he's using it. Actually, I would say this picture is backwards because you would want the blade on the other side to cut off the excess on the outside. But you would unspool your cables, you would line them up properly. In here, you will see a picture representation of whether they're using T568A or T568B. You just need to be sure that on both sides of your runs, you're using the exact same standard. So when you pick a standard, stick to that standard. Otherwise, it can cause problems in the network. Questions so far? All right. Man, we're almost there. Two other sets of tools you'll use regularly. You have your multimeter, which will tell you if you have connectivity within your network or continuity. Really nice thing to have if you don't have other tools available. And then if you're dealing with a huge switch with horizontal runs that go into the walls, it can become very difficult to find, well, where does this tone come out? Or where does this cable come out? How do I know which one is the right one? You can use the toner and probe, otherwise known as a fox and hound. You can plug the cable into here, and then you take the probe into the server room and find out which one of those wires actually is the one you're trying to work with. Little mental note, if the signal goes into a switch, for some reason, the switch eats that signal. So the tone does not come out somewhere else in the signal. The switch itself eats the signal and it does not generate it. So you'd have to pick it up on the lines themselves. Questions so far? All right. Last two tools we're going to be going over for this particular technical session is our loop back plug, which literally, as the signal is coming out of the NIC card, sends it right back into the NIC card. And all it's used for is you plug it in. If you see the lights blinking on your NIC card, it tells you that your NIC card is working. It just lets you know that physically the device itself is functioning. That is what the loop back plug does in a nutshell. There is a software version of this. You have the loop back address where you can do the same thing, but this tests it at the physical level. The other thing we need to be aware of is a cable tester here. Go ahead. Yes, Rienzi.
That little thing, you can see that on the screen somewhere, or like, how do you know it, you know, where does the signal, like, how do I read that it's working?
Well, when you plug this into the back of the computer, you have a network indicator light on your NIC, which tells you if data is being transmitted. It blinks on and off. So when you plug this in, it'll blink, which means that data is being transmitted, so your NIC is physically okay. So that's all that device does. So lets you know that physically it is functional. It's got power. The NIC is reacting to a network. Then lastly, we have this cable tester here. This is actually two pieces that are linked together. They do separate out. Excuse me. You would plug one end of a network cable in here, other end of the network cable in here, and then these lights would light up in sequence and make sure that you have connectivity equally across all lines. Now, if one is blinking 1, 2, 3, 4, 5, 6, 7, 8, and the other one is blinking 1, 2, 8, 7, 4, 3, 2, you know it's a bad cable. It's not wired the way you want it to be wired. So a cable tester will tell you if the cable is functioning properly. It'll also tell you if there's a break in the cable, because you will get no light up. Like it might go 1 blank, 3, 4, 5, telling you that there's a break in the number 2 wire. So a pretty useful tool to have in your toolbox, and they're thankfully relatively inexpensive. Questions so far? All right. Now, remember how we talking about you had T568A and T568B, right? That's if you have it and it's A on either side, that's called a straight through cable. That is your standard network cable. Problem is if you do that, hook up a standard network cable from one computer to the next computer next to you, they can't talk to each other because both of the outbound ports are on the same lines. So you have to actually switch those over, and you would have standard T568A on one side and T568B on the other. That way the outgoing of one would be on the incoming of the other. And that way you could directly wire two computers together or two switches. And that is called a crossover cable. You're crossing over between the two different standards, T568A to T568B. Anybody in here have the original Xbox at some point in their life? Not the 360, I'm talking about before that, the original Xbox. So back then, they allowed for you to be able to hook up two Xboxes together. But they had this proprietary cable you had to buy. Cost you about $50 for this cable. It's only about 3 feet long. But it allowed you to hook up two Xboxes together so you could have, a party, play Halo against each other or whatever. All that was a crossover cable. Anybody in networking, as soon as they saw that, they knew exactly what it was. It was like, man, you're charging people $50 for what is essentially a $5 cable. But they're playing on people's lack of knowledge in the industry. So, yes, Rienzi.
I thought you just said that we shouldn't, that if once we use a cable, we should stick with that one.
Yes, when you're wiring a network, because here's the thing, if I have a crossover cable, like if I wire T568 for my computer on that end, but the end of the cable that I plug into the switch is T568B, they won't be able to talk. The crossover cable only works when I'm putting two computers directly together with nothing between them. No hub, no switch, no nothing. It's literally just, I'm hooking up my laptop directly to my computer through a network cable. If I have a crossover cable, I can do that and they can talk as it like it's a peer-to-peer network. And we also do that to talk between switches. So a crossover cable from one switch to the next switch. Although more modern switches have what's called auto sensing and they can automatically change between the two. So any questions on what the difference is between a straight through cable, which is this one right here, which is the same standard on both sides, and you have a crossover, which is A on one side and B on the other. And it shows it right here where it's switching the cables around for you.
Okay, so can you explain to me again why I would do that? Is it, I get that it's two devices that are dissimilar, but
well, say you're traveling on an airplane and you and your colleague are working together on documents, but you don't want to share the same computer. You each have your own laptop. You want to be more efficient. So you can actually take a crossover cable and plug your laptop into your coworker's laptop since you're sitting right next to each other, and then you can share files between each other. If you have just a straight network cable, you wouldn't be able to do that. They wouldn't be able to see each other. It wouldn't work. You would need something in between, like a hub or a switch to facilitate that conversation.
okay, so there's nothing specific about the computer. It's just that they're just two different computers and there's no medium that's helping the community. That's it. That's the only qualification.
Kind of, but okay. So if you look at the cable here, let's say on computer A, let's say line 1 and 2 is their outgoing lines. That's where they send out their outbound communications, right? And then line 3 and 6, that's where they receive their communications on. So if I have a straight through communication from computer A to computer B, I'm sending outbound communications to their outbound line. They're not listening on that line. They're trying to talk on that line. So we can't hear each other. So what we need to do is flip those. So like over here on PCA, I'm taking my two outbounds, the line 1 and 2, and I'm moving it down to lines 3 and 6 on there. So my outbound is going to their inbound.
Makes sense now.
So it allows us to be able to talk. Does it make sense? All right. Any questions? All right. Yeah, it could start off as an A and end as a B, or it could start off as a B and end as an A and be considered a crossover. It's changing between the two standards. Doesn't matter what one side is and what the other is, as long as it's the different standards on either side. That's what makes it a crossover. Yes, Humberto.
Yeah, but in modern devices with the sensor that you mentioned, you don't have to worry about the crossover or straight.
No, we do.
We do
But,
still?
Okay. The hub is where the collisions were happening. And the collision was just two devices talking at the same time, so the data is running into each other. This would be a direct connection between two computers. So I wouldn't be using a hub or a switch.
No, I mean, I understood that the modern devices have a sensor that let them know if it is going to be a direct connection or a crossover.
Oh, no, that is on specifically on switches, not on computers. That's on a switch. So if you plug into a switch and you plug one switch into another switch, it knows off the top, off the bat, whether or not you have a crossover connection or a straight through connection, and it will automatically switch between the two. So it has that ability to sense between those two cables, but that is specifically with switches. Sorry about that. All right.
Thank you.
Any other questions? All right. With that, we've finally reached the end of this technical session. We should now be able to define a network and give examples of networks: MAN, CAN, LAN, WAN, PAN. We should be able to identify the devices that are used in these particular networks, be able to identify the types of network cables and connectors that we utilize, and also be able to recognize the most common network tools that we would use to work on our networks. Any questions?
Yeah.